So for this question, I did the working already. I'm just gonna explain how I got these, okay? Due to time. So we have the triangular base prism, and we know it's a prism because it's a solid basically with identical cross sections. So this cross section here is identical to the one at the back. And if you had this like maybe this cheese in this shape, you could cut it along the triangle side, going all the way to the back, and you have the congruent faces. In other words, faces that have the same size, same shape, all the way through the back. So that's what we call a prism. Okay, and the first question asks us to calculate the area of the triangle. So we use the formula half base times height. And so we're looking at this face right here. Let's color that. So we're looking at this triangle ABC, right? So this is the triangle we're looking at. And to find its area, we use the formula half base times height. Now, this is the height, right? The height and the base are perpendicular to each other. The height and the base are perpendicular to each other. They meet at 90 degrees. And we know that because we can clearly see that there's a right angle here, and the two sides, being base and height, meet at 90. And so the base is 10 centimeters. We put that in. And the height is 7. All right, that's right here. And now half of 10 is 5 centimeters. And 5 centimeters times the height, 7 centimeters, is going to be 35, because 5 7 is 35. And centimeters times centimeters give us centimeters squared. Next, we look at the volume. We're asked to find the volume of this solid, the triangular prism. Notice that we found the area of the triangle ABC to be 35 centimeters squared. To find the volume, we multiply by the distance between the two identical cross sections. Notice I said that there's a triangle behind here, and there's one in front here, and the distance between them will be this distance, this 12 centimeters. All right, so we just basically look at two identical vertices, for example, from C to F, which is 12 centimeters, based on the fact that this is 12. So going right up here, this is also 12, right? So the distance between the two triangles is 12 centimeters. That's what we call the length. So the volume is equal to the area of the identical cross section multiplied by the length or distance between both uniform or cross section. So it's be 35 centimeters squared times 12 centimeters squared. 12 centimeters, sorry. 35 centimeters squared, that's the area of the triangle, times the distance between both triangles, which is just centimeters. Now we multiply these, we're going to get 35 times 12 being 420, and centimeters squared times centimeters give us centimeters cubed. We're looking at the fact that we have a 2 here, multiply centimeters, which is the 1 there. Technically, we don't usually write that, but just add these, right? So that will give you centimeters cubed. Right, so it's 2 dimension times another dimension, give it 3 dimensions. Okay, now let's move on to finding the total surface area. All right, this looks like a total mess, right? But what I basically did was to identify all different faces. So this solid basically has, let's clear this quickly. All right, I'm going to explain this right now. So this solid here has several faces. How many faces it has? Well, it has one on the back here, that's 1. Underneath, right, that's 2. Then it has this one on top here, right, that's 3. And then it has this triangle, that's 4. And then this triangle, that's 5. So we have 5 faces. So what we do, we find the area of all the faces. Okay, so let's look at this face right here. This is the rectangle behind here. Rectangle A, B, F, C. All right. For some of you may not be able to see that clearly, so I can just quickly highlight it. That's a rectangle, right? Just turn, because of how the solid is turned, it doesn't probably look like a rectangle, but it's a rectangle basically. And you know the rectangle, the area for the rectangle is simply what? This length times this width. Length times width. Just multiply them and get the area. Now this rectangle, right, this measurement is 7 centimeters. What is this measurement here? C to F or A to D, because they're the same. Well, recognize that AD is connected to this rectangle, right? And this side BE will have the same length as AD. So AD therefore is 12 just like BE. So this is 12 centimeters, which implies that this here is also 12 centimeters. So to find the area, just multiply any two adjacent sides. Now this side here is what? 7 centimeters. So this also must be 7 centimeters. Opposite sides of a rectangle have the same length. Multiply any two adjacent sides, any two sides next to each other, and you're going to get the area. So that area is going to be 12 centimeters by 7 centimeters. That's for the rectangle ADFC. All right, let's go around the shape and mention the vertices A, D, F, and C. Okay, so we're going to add another face, the area for another face. What other face do we want to look at? So we can look at another face. Quickly, highlighter. Let's use green. This one down here. Okay, so this is a rectangle as well, obviously, right? And we can find the area of that quickly by one moment. Okay, so for this rectangle, we can no doubt see that the longest side is 12, the shorter side is 10, so it's going to be 12 centimeters times 10 centimeters. All right, and that's rectangle what? Good. Let's start with A. A, B, E, D. Okay, and okay, 12 sevens, that's 84. And centimeters squared. Since we're multiplying one dimension by another, we added the dimension, so that's 2 dimensions, so it's centimeters squared. 12 tens, that's 120 centimeters squared. Let's look at another. Do we have another face? Yes, we have this face that is sloping downwards. All right, so let me just quickly shade that so you can see it clearly. So we're talking about this face here. Let's use a yellow color here. So that's this face right here, coming right down. It's a rectangle. And so to find the area of that rectangle, we multiply length by width again, which is going to be, now if you look at this side here, let's call it the length, call it the width. They're the same measure. So that's basically a what? A square. And so we're looking at the side, let's start with B, C, F, E. We multiply length by width, which is 12 centimeters times 12 centimeters. That's 144 centimeters squared. Let's add. So that's the third rectangular face. We don't have any more rectangular faces. So we're gonna just basically look now at the triangular face. We have 2 of them, right? One there, and one there, as we mentioned before. And we already worked out the area of the triangle, right? Triangle has 3 vertices. In this case, it's A, B, C, right? A, B, C, which is a triangle. So to find the area, find half the base, which is 5. Half of 10 is 5. 5, 7, 35, which we already worked out already, right? So that's going to be 35 centimeters squared. Now, since this triangle at the back here is identical to this one here, we're just simply going to write its area. Now we can use the vertices. We can say it's D, E, F, triangle D, E, F. All right. I probably could have put the triangle symbol, but it's okay. They're identical. All right. So when we add these two, we're going to get 70 centimeters squared. Why are we adding them? Because, well, the area of one face is 35. The other is 35. The total so far is 70. All right. So when we add up these figures, 84 plus 120 plus 144 plus 70, we should get 418 centimeters squared. All right, and so that's how we do it. Hope this video was helpful.